Great. All right. Hey, everyone. My name is Aman, and I'm a product manager working on Jukebox, our feature management product, which is a part of the ML platform. I'm joined by Daniel Christiansen, who is a staff engineer on the home product area, and he's going to be talking a little bit more about how his team uses Jukebox in their workflows. And I know this is the first talk of the conference, so I'm going to kick us off on a high note. No pressure here by diving straight into how we manage features at Spotify. So we're going to be talking a little bit about the ML platform at Spotify as a whole and how Jukebox fits into that. We're going to talk about how Jukebox works and why we design it this way. And we'll even talk a little bit about how to implement Jukebox in your workflow. And then we'll talk a little bit about where we're going with this platform. So let's first kick this off with talking about Spotify's scale. So Spotify is a product that's used all over the world. We have 365 million monthly active users. We're available in 178 markets, and we have over 4 billion playlists, tons of catalog items. This slide has some really big numbers, but the main takeaway is we have a lot of data and it's growing constantly. And all of this data is meaningful to continue to provide a better experience to our users with the number of use cases leveraging ML increasing constantly. You can see here we have to manage thousands of models and hundreds of thousands of requests per second with over 50 different teams using ML for a variety of use cases. In fact, we use machine learning in just about every part of the experience, everywhere from personalization, like creating playlists that customers know and love, such as Discover Weekly, to ad serving, improving onboarding, improving the quality of our messaging, and accelerating our ability to grow in new markets. And just as a refresher at Spotify, I think Jim covered this pretty well. When we think about data, talk about features specifically, we're talking about looking at operational data and transforming it into sort of analytical and feature data, which is enriched with metadata. And so we think about this as vector representations that are constantly undergoing change across different ML use cases. And while Spotify's scale affords some really amazing opportunities to build a great experience, it also provides some unique challenges that come with scale. So from a technical perspective, we perform online inference for a variety of use cases. For example, showing you a new release from an artist that you love on your home screen when you open up the app. And a number of these use cases utilize near real-time, low latency features. That means when users interact with a product, we can dynamically update model predictions about what to present next. On top of that, when ML engineers are creating and managing features, we have inherent challenges around offline and online consistency of features, like needing to backfill data for a feature to evaluate its impact on model performance. Furthermore, because of the highly autonomous nature of our engineering function, to move fast, engineers often need to unblock themselves and may not realize that some features are common across different use cases across the organization. And so they end up recreating features themselves, which is costly from both an engineering time and from a data duplication perspective. Needless to say, features are a huge problem at Spotify. So just a brief history about our platform. Around 2017, we kind of discovered this need for being able to support machine learning at scale and decided to build an infrastructure team focused specifically around ML, whose core mission was to increase machine learning productivity. And we did that by building common tooling and establishing standards for ML development at Spotify. This ultimately led to the creation of Jukebox, which was a Jukebox 1.0, which was a collection of libraries that sort of helped manage different data tasks. However, these data tasks didn't really have a notion of a central strategy around features. There was no integration with Jukebox with the rest of the ML platform. We didn't really think about features as a first-class citizen, and historically, users mostly dealt with data endpoints themselves. So we went back to the drawing board in 2020 and decided to think, how can we take a different approach to features that sort of takes more of a managed, sort of centralized platform approach? And that's ultimately what led to Jukebox 2.0. And Jukebox is actually part of a broader ecosystem of tools here. So we have tools like Salem, which is a Spotify-wide platform for serving ML models online. Our ML home interface is sort of the UI for our tools and applications. We have Spotify Kubeflow, which is a managed platform for Kubeflow. And specifically, we have Jukebox for features and which sort of spans the entire breadth of the ML workflow. So that leads us really to where we are now. So Jukebox is a platform, which is a platform as a service for working with machine learning features. It helps machine learning practitioners focus on what features an ML model needs, rather than dealing with how to find those features, or how to join them together, or how to find features, or how to make them available in an online store for inference. So we take the functionality that we kind of expose from those libraries that we built before and expose it as a service API. And for producers, that means registering a feature in the feature registry that we have and loading an offline source for it, which basically means specifying the location and some metadata about the feature. And you only have to do that once when you're producing the feature. For consumers, users can specify their desired features, and Jukebox joins them together to produce a training data set for their model, and then makes those features available in Bigtable or GCS storage for real-time for real-time or batch inference. You just need to load the features online, and then you can make them and then use our feature reader library to read those values from the specified features at time of inference. And so we really sort of take these, really sort of taking a approach of taking higher level abstractions, which connects the dots between all of these internal libraries. So you only have to focus on your workflow and not how data passes between components. And so in that way, Jukebox can automatically convert between Abra and TF record, registers features when you're interacting with it, joins those data sets, and then computes underlying statistics about the data, like profiling information. And some of the benefits of this affords is really taking a sort of centralized approach for management, so users don't have to worry about latency from other teams and other teams' feature stores or multi-tenancy. They can also build off of a standardized workflow and reuse and share features easily with other ML practitioners. And you only need to register your features and can reference them by name, which simplifies code and reduces chance of errors. We've also made some, significant improvements underneath the hood by improving sort of the ability for point-in-time joins at time of the create training data set. And as we move towards versioning and maintaining feature transformations, we can adapt and expand the API to conform to those needs as well. And this platform-based approach allows us to kind of get more flexibility with our development as well. So we can change implementation details without users needing to be involved. So we can update internal logic and how data is passed without requiring users to update their workflows. For instance, if we need to conform to new privacy preserving requirements, we can do that all underneath the hood with Jukebox. And it also makes it easier to tie in with other parts of the ML platform. And so ultimately, we've created this kind of new user-focused centralized workflow. And I'm going to hand it off to Daniel to talk a little bit about how he uses Jukebox in his day-to-day.
Okay, I'm just going to assume people hear me. So home is a product area at Spotify, and we're responsible for what shows up on your home screen. Basically, like what we're trying to optimize for is the user's long-term satisfaction, the listener's long-term satisfaction when they get to Spotify. And to do that, we have many models, we have many teams, and we have hundreds of features. And it's all powered by machine learning. Yes. I put an asterisk next to the 5 feature stores because we actually use more than that. Some are just not designed as feature stores. And one of the things that we're trying to do is contain the blast radius of whenever. So machine learning models require data from all over the place. We basically use data from all over Spotify in home, but you don't want to depend on that in production. Because one of the things we're trying to do is contain the blast radius. So, like any system where we're like, taking, billions of things that we could recommend and we're recommending just a few, we have many layers. So like we have, content pools, some filtering layers, some, calibration layers, and all of these add value. If any of them goes down, we're going to have problems. Can we go to the next slide?
Yeah.
So we get features from many places. So log-based features are probably the workhorse. So these are like, what are you doing in the app? What are you listening to, etc. And these come in batches, or we also have streaming versions of most of them. Another powerhouse is embedding. So because we have 4 billion playlists, we have 3 million podcasts, etc. Like we need to have embeddings to be able to work with these at all. And then there's, of course, contextual features like local time, what kind of device are you accessing with, etc. And we have central teams that own some of these things, like actually collecting the logs is something that's owned centrally. Creating some of the embeddings is owned centrally. But most teams at Spotify actually do have to write geo pipelines in order to get data into the system. Can we go to the next slide?
Yeah.
Okay. So feature stores aren't like key value stores. They're actually there to support a feature engineering workflow. And so what does that mean? Like, you start with a hypothesis. Like, for example, the podcast team thought, BERT embeddings of the episode description would be useful for arranging the episode shelf, like the episodes for use shelf on your homepage, which is probably there if you open up Spotify. But what does this mean? Like, first you have your hypothesis, and you have to do some data engineering. Where are these episodes, descriptions coming from? Like, there's an ingestion pipeline, and you have to hook into that, and then you have to get this into your model. So you have to do an embedding. In this case, we're using Hugging Face to create a BERT embedding. And then you have to offline test it. So we do logging that lets us test things offline. Because you want to test over a few weeks and of data, and it's the easy way to get some testing done. Then you have to run an A/B test, because hey, offline isn't always accurate, and simulations aren't always accurate. And then ship it. But can we go to the next slide? The reality is it's not so linear. It turns out episode vectors didn't work the first time or the second time or the third time. You have to iterate. And so we did more data engineering. We tweaked the embeddings. We did a lot of testing, and we shipped it. And then of course you have to monitor it, because this feature hasn't alerted, but many times the data changes, and this will cause your model to just go sideways. So monitoring is super important. We're not going to really talk about that today. What I'm going to talk about is, if we can go to the next slide. So I want to talk about when I first met Aman. So home is one of the early applications of machine learning at Spotify. So that means we did a lot of things on our own. Like, we created our own, serving infrastructure, our own training pipelines, our own feature stores, and our own work feature logging. And we had two sets of feature engineering workflows. And I had been leading this ML infra working group in home. We had just adopted Salem, and Salem is great. So Salem is our internal model serving platform, which also does feature logging for us with GDPR compliance and everything. So individual fields are encrypted. And if you were listening carefully to that last paragraph, I said that we have two feature engineering workflows, and this is because our feature engineering with context features or near real-time features ended up being we would put the feature into production, we would log it for a couple of weeks, and then we would train off of that. And this is based on that rule 29 of Google's I think feature engineering rule, or no, ML rules, which is it's a good idea. It means you have your online offline consistency. But what it did mean is that to actually ship a feature would take weeks. You'd have to put it in production, which is work. You would have to log it for a while, and it might be weeks, and then you could train off of it, and then hey, maybe it didn't work. So that was one workflow. Then another workflow was on teams that didn't have any real-time features. They could just basically write SQL queries off of our ETL based data, and actually be able to model their feature, do offline analysis, and then start an A/B test fairly quickly once they had a feature that worked. And these teams were shipping features much more frequently. Can we go to the next slide? So problem is that, we were moving to Salem, which meant, new capabilities. We were going to have these, everybody was going to have feature logs, which is great. I mean, using these features, before teams had to actually write their own feature logging, it was expensive. So you would only do it if you really, really needed it. Now where everybody was getting it and everybody was excited about these features. Like, if you think about it, something like recommending podcasts, if you don't know what time of day it is for your user or don't know what they already listened to today, that's not really a good place to be, but that's where we were. So, we knew we wanted to be more reactive, which meant, these longer feature engineering cycles. And we also had this problem. We were starting to look into reinforcement learning, which, is great, but it also means your A/B tests have to run longer to validate changes. And so we were looking at like lots of things that are going to be impacting our engineering, feature engineering velocity. Can we move to the next slide? So at this point, we started looking at what was out there and in the working group, and pretty quickly we found Feast, and we found I think Airbnb Zipline was the thing that was available, was there already, and you'll hear a lot about these in the next couple of days. But it's like just killer features for fast iteration are point-in-time joins. It turns out like data leakage is really a problem, and like we just had a feature last week, which we think is data leakage. It like worked offline, didn't work online, which is the typical thing that happens. Automated backfills, even at Spotify, we have good infrastructure for orchestrating your pipelines. Like we wrote Luigi back in the day, and we have our own newer things, but it's still a pain. It's still like when you have a new feature, you have to backfill it, so you have maybe a few weeks of data, assuming you're generating enough data that already existed. You have to backfill it, which is a few weeks of backfill that you have to keep an eye on, yada yada. It just that eats up a day. So if you have automated backfills, this is going to save you a lot of time and heartache. And then finally, streaming ingestion. This isn't strictly necessary, but the truth is that like this is when we started having problems, was when we had near real-time features. When we had near real-time features, then we couldn't use like hacks to create our data set to do our training. We had to, right? Like we could theoretically, but we would have probably made mistakes. It wasn't worth it. Engineering teams actually just put the features into production and trained off the logs. Next slide.
And Daniel, just a heads up, we only have a couple minutes left on time here.
Okay.
For reference.
We're actually okay. Yeah, we can go 5 minutes. It's fine.
Okay, great.
We can go to quarter past. That's fine.
Are we on the Jukebox 2.0 slide yet? Okay.
Yes, that's correct. Yeah.
Okay, great. Yeah, I don't know what happened to my Zoom. It just went sideways right when I was starting. So at this point, Aman was, this is when I first met with Aman. He was hired as a product manager for this team that had developed Jukebox, we'll call it 1.0, but it was a set of libraries that'll help you build a feature store. And this team had also done an analysis of Feast recently at this point. And I think it was Aman's first week, and I delivered him like Home's impending doom and, or I would say feature engineering crisis. And I'm pretty sure, I pointed him to other parts of the company that were having the same problem. And sorry about that, Aman. But in due course, Jukebox 2.0 made it onto the roadmap. And if we can go to the next slide. So basically adding a new feature is now a little bit more complicated. You have to register it. Then you do an offline load, and then you can prepare your training set. The register actually gives Jukebox some data about the feature. We have a fairly robust set of systems for tracking data lineage just based on something we call a feature endpoint. So like just having that endpoint gets you started. Can we go to the next slide? So, in the old days, what I was talking about, the second workflow, we could just create we could create a training set just writing a SQL query, but you actually had to know a lot about the features that you're joining. Now, by separating into a feature producer and a feature consumer, the producer has to know, about where the details of how features are stored and et cetera, but the feature consumer doesn't. So, I'm going to give you an example of like the BERT embedding vectors. We might register the feature and say, like, do we have, a float vector that's owned and maintained by the home podcast team. And we will specify an online and offline storage location. And then, a human description. But, we attach a name to it. Like in this case, podcast description BERT embedding. And that's what we use from now on. So if we go to the next slide. So the consumer of the feature only needs to know the semantics of the feature itself. They don't need to know, which is documented in that registry. They don't need to know anything about, how it's partitioned and the timestamps that are used, et cetera. Yeah. Can we go to the next slide?
Yeah.
Are we on online data loader?
We are.
Okay, great. So once you've gotten your feature working well offline, we want it online as well. There's an API call to do that, which will load it from just about any format into Bigtable. Bigtable isn't like, the be all and end all of feature stores, but it's a very simple, scalable, managed source store. So it's the first one any team that needs to store a feature would probably look at. Going back to our BERT embedding, we don't actually, use this call, but it's okay because when we register the feature, we're told it where to find the feature. So in this case, we just write it directly from our pipeline into an online source. Next slide. So none of this would matter if we couldn't serve online. So we actually have something in Jukebox called Fonzie, because it gets your features. And, in home, nearly all our models have a Java-based backend, which will collect the features and from various sources and throw them at our Salem, which is our features serving, our model service. And, then it will spit out a prediction. It's not perfect. Like ideally, we would actually be able to do, feature loading within Salem. So if we go to the next slide, I'll show the ideal. In the BERT embedding case, all you need to do is specify that, episode description BERT embedding, and Fonzie will figure out how to get that feature, get the latest feature. Can we go to the next slide?
The home use case, Daniel?
Yeah, okay. So, I talked about producers and consumers of features. It's actually, every ML team at home both produces and consumes features, some for themselves, some for other, that are used from other teams or to other teams. So there's only like a handful of teams at Spotify that actually are just dedicated to producing features, which means a lot of features are produced by product teams. You can go to the next slide. So just Jukebox 2.0 is actually an easy to adopt technology within the Spotify context. First, adoption can be piecemeal, which is pretty good. So you can actually like register somebody else's features. You're not dependent on them registering it. You can do it yourself. The feature registry is useful internally. So in this episodes for you example, it's a ranker. So it like ranks these episodes, but we already have a ranker that's like a general ranker. So you can actually now register the features from the general ranker and use it in this episodes ranker. So you don't have to like recreate those features or even think much about how to get those features from the other model into your model. And Yeah, well, Jukebox adds a step. I mentioned that earlier. It's actually like it's a bit of YAML, and what it's replacing is like writing pipelines or you know it, doing backfills, which are both painful operations. So like you're doing a little bit extra work, but it's replacing a lot of work that you now don't have to do. And I would say just like Jukebox is like most platform technology is Spotify. It builds on what teams are already doing. It's built on like a good, if you're already doing best practice, it's just leveling things up a little bit and you're getting things in exchange for it right away. Like there's a clear benefit. And now I'm going to hand it back to Aman. How much time do we have left?
Sorry, yeah, we're like a 1 minute.
Okay.
Yeah.
Cool. No worries. We can
go to
wrap
2
up
minutes. Questions can be taken.
Okay. Sure, no problem. Cool. If you want to hit the next slide. And we can maybe keep hitting next slide every 10 seconds or so, and I'll talk through this. So
we can take 3 minutes, and we're good. Take 3 minutes.
All right, cool. Every 20 seconds, and I'll send next if it's too long. So thank you, Daniel, for going through like how engineers will use the Jukebox API and Jukebox service and their workflow. We do also have an accompanying UI to go with this, where primarily this is mostly at this stage for exploration of new features. So, users can land on the gallery, which was the previous page, and click to sort of find more information about features that other teams have registered, and see sort of who's the owner of that feature, what the offline and online source looks like, as well as more metadata around the feature. So you can look at the feature details, and if you could go back one more slide, actually, just super quick. Let's see, or rather go back a couple of slides and see sort of what the what the metadata is. So you can see the scope, life cycle, quality of the feature, and basically the reason we build this in is so that users can actually have a better understanding of what's going into the feature itself, and reach out to other teams using that same feature. So we also track model lineage of which teams are using certain features, really with the intention of sort of building that collaboration and trust between features. And you can hit the next. And so from here, this strategy gets us to sort of address the two main pain points we saw above and before, which were technical and organizational. I mean, Spotify is a unique sort of example where we have so many different ML use cases across the company that we need to sort of design a product for. And so our challenge is really to prioritize the right use cases. And in that case, where Daniel was mentioning before with things like point in time joins, we interviewed a bunch of different customer teams and sort of identified like what do we need to prioritize to have the most usable product across the company. And this also helps build trust into the product, because at this point we're actually adding richer context and metadata behind the feature that will sort of enable and sort of create this flywheel around building for reuse. Our intention is to sort of scale out this kind of feature marketplace strategy where users will hopefully and are currently at the moment, as we're seeing like through adoption, using other teams' features, either within the same product area or across product areas. So we're actually reducing the amount of data duplication and engineering work through sort of building this centralized platform. You can hit next. And so just a couple of like super quick, some of the things we're looking at in the future are automation, building out more automation between our platform, increasing our model interpretability and observability through feature importance, and the ability to sort of, maybe swap out or trade off between different storage or processing backends or engines for cost or performance reasons. So there were some questions in the chat about like, do we see like, do we have like data silos? It's actually more depending on the use case. We might have different performance requirements for features depending on what the use case is, whether it's batch or real time or near real time. And so that's really where we can start playing around with the backend for Jukebox to sort of enable more of this functionality. You can hit next. And so some of the lessons that we've learned, I mean, first off, I would say listen to your customers, and if you can, rope them in to work with you. After Daniel and I had that conversation over a year ago, he ended up joining our team for a quarter and actually helped us build out that first version of Jukebox 2.0. And so that's really like a good signal that you're building for the right use cases if you have engineers across the company willing to collaborate with you. On top of that, I'd say feature stores are an evolving space. Our folks at Logical Clocks, our friends here, have built a really amazing product. So depending on your scale, depending on where you are on your journey, it might make sense to look at buy instead of building your own infrastructure. And lastly, I think about scale early. You don't want to land up into a situation where your strategy doesn't scale because of the approach you've taken with your data storage or with your infrastructure. And so sort of this is a great opportunity, this conference, to learn from mistakes, but also sort of lessons learned from other companies and figure out what applies to your own specific use case. And that's an overview of Jukebox 2.0 and about how Spotify uses features. If you have any interest in potentially using Jukebox, learning more, you can reach out to me and we can have a conversation. And on top of that, we're also hiring across the board within ML platform, not just in the feature store space, but also across different use cases or different products, as well as across the home product area that Daniel works on. So you can always feel free to reach out if you have any questions or are interested in working at Spotify. But with that, thank you for your time, and thank you for the team that worked on Jukebox along the way.